Hello students, here I am making another video for unit Algebra 2, unit 5, and this is lesson number 6. And the topic is symmetry in equations. So in this lesson most of the equations will be given, and here is the learning target. I can complete graphs of even and odd function if I know what the graph looks like. That means if they will give you half of the graph, you could easily draw the other half. And then here there is the second part is you can identify whether any equation given is odd and even. Here is the one I'm clicking on, the cumulative practice problem right here, the first problem of the day. So how do we know which one is which among this? There are four, and we'll see which among this is even and odd. So how do we know? First, let me take this. Okay, so how do we know whether the first thing is, remember, so far we have been doing that identifies if the new function is, if the input of the new graph and the input of both are same, and they give you the same output, both are with the opposite inputs. If the output is same, then we say this is a even function. But if the new function, and then you get back the same thing, this new gx, you get back f of x. So this basically is a reflection over the y-axis. But then if you get back your original function, so if f of minus x, and it coincides with the original function, then it is a even function. Then what about odd function? Odd function is the new function is minus f of minus x, this part. So basically you are reflecting over the y-axis first, and then you are reflecting over the x-axis. And if you happen to get f of x, then that is odd function, and this is even function. Let's see how to use which of this function given is even and odd. The first one is, so the first is, let me write it here. So even is if you replace x by minus x, and you get f of minus x is same as f of x, so that becomes even. Let's check the first one. So in this case, if you replace x by minus x, to see what's happening is, I want you to write this step so that you really understand what's going on. So replace by minus x, and 3 times minus x raised to 4 plus 3. So I'm replacing this x by, so this x is replaced by a minus x, and when you work it out, you get 3 minus x raised to 4. What is minus x raised to 4? Is minus x minus x minus x minus x 4 times, and you can see these two negative become positive. Eventually you get positive x raised to 4. So you get raised to the power 4 plus 3, and that's exactly the same as here. So that means this is f(x). So you begin with f of minus x and you ended with f of x. Clearly it satisfies the the formula, or the rule that the output is this. What basically this means is, when you reflect over the y-axis, and if you want to check this using the Desmos, you can usually graph and see what's going on. You'll see that there's a y-intercept, the graph is at 3, and kind of a graph, something like this. You can see it is really, if you reflect, it will always give you back the same thing. So this is an even function, and you can see it, if you reflect over the y-axis, you get back the same thing. This is not odd. Okay, so it is even. So even function. And why it is not odd is you can, if I write, so why is this not an odd function? Let's take down minus of this. So this f of x, we got this part, right? And I'll take this off here. And if I had to take a minus of that, so that will give you minus of this whole thing, 3 raised to x raised to 4 plus 3. And that will be minus 3x raised to 4 and minus 3. And this is not f of x. So that's not. So there is a shortcut trick also to do this kind of problem as we progress here. So in this 4 examples, you better write all the steps why it is. Or you just see there's a degree this polynomial. Now this is a polynomial of degree 4. So 4. So no matter if it is degree 4, and if you replace x and minus x, so raised to 4, let's see, it will always gives you back the same thing. So this becomes even. Look at the next question here. In this case, let's replace x by minus x and see what's going on. If f of minus x equals minus x raised to 3 minus 4 of x. Okay, I missed that. So this is minus x. So when you work this out, this minus x, minus x, minus x. So one of the minus x will remain, and this will be 3. This will be negative, negative, positive, and you get x. So this we can write it as minus of. So there's a minus and there's a plus. You can undo. You undo distributive property and write this as x raised to minus 3. And the inside, you see this. I'm sorry, this is 4x. So this will be 4x here. So that means this part is the same as f of x. So you replace back here. So f of minus x, you get minus of f of x. So this is odd function. So f of minus of x is, that's because when you have minus of f of minus x is f of x, this is the definition for odd, but it is the same as f of minus x is same as minus. Both are one and the same thing. So instead of minus this, and the reason to write this is just to understand if you reflect twice over the y-axis and then over the x-axis, then you get back the original function. So that's the odd function. Or you reflect over the y-axis. This is same as this is reflect over the x-axis. Okay, this is the C. Again, let's replace. Let's put x equals minus x and see what happens. So f of minus x is 1 over minus x the whole square plus 1. And this is 1 over x squared plus 1, that is f of x. So clearly you can see this is even function. And you can by just looking the way when you look at it, you know the thing, how the graph, whether it is, you'll get back. So this minus sign vanishes and you get back. So actually if you see the Desmos graph, it's something like this. So when x is 0, it's like 0, 1 here. The next question, let's put x equal is minus x. Watch this. There is a x square here. This will make it a even because of that, and this will make it a odd. So whenever there is a even and odd together, even and odd plus odd, this does not become neither odd nor even. So that's what that means. And you can also check. Let's check it out. What I'm saying is, let's plug it in x by. So replace x by minus x. F of minus x equals minus x squared plus minus x and minus 3. Now this will be x squared, this will be minus x, and this is minus 3. And you can see the final this expression is not the same as this, right? So this is not even. And if we try to take opposite of this, let's see, if I want to write minus of f of minus x here, multiply minus 1 both sides, so I multiply minus 1 and multiply minus 1. So this plus will change to minus x squared, this minus x will be plus x, and this minus will be plus 3, and you can see it is not the same thing. So what that means is, it means f of minus x is not same as, so this minus, this part, minus of f of minus, you don't get f of x, so that's not the original function, so that's why this is not odd. Okay, by now I think we should be able to confirm that. Two things you should remember that if you have something plus or minus, if this is even and this is even, you'll always get even. Or if it is odd plus odd, will give you odd. But even multiplied by even will give you even. Odd multiplied by odd will give you even. But odd multiplied by even will not give you so this will be neither. So you need to be very careful there. So whenever you have an even function or even, two evens, it's like plus plus is plus, minus minus is plus, something like that. Minus and plus is. So this, I'm sorry, this is going to be odd. You may say why? So what could be the reason is, you can just take a simple example, is x cube is a even odd, and let's say multiply it by even x raised to 4, and that will become, so this is separately odd function, this is even, you get x raised to 7, and that is odd. That's odd, that means, see? Okay. One thing is, if you have both even gives you even with the plus and minus, and even odd and odd, but if it is odd and it is even, then neither. So neither you get even or odd. So those are the ones that we'll see in the next problem. In the second question, I want you to try yourself, pause the video and try yourself. So they give you from 0 to 5. So this graph is given this way. What you're supposed to do is, the function g is even. So you're supposed to do another one which is even and takes the same values of f for 0 to this. So how do we do this? So the new function g, the graph of g is same as f for 0 to 5. So that means I need to graph g, so that will be overlap, coincide this side. That means, and it has to be even. So if it has to be even, so whatever this point, I'll have to take exactly somewhere here. If this is the point, then that will be -4 and somewhere here, and like this. So this will give a function g such that g of minus x is nothing but f of x. So this graph if I have this thing, if I reflect the whole graph, so this part, the whole thing, if you reflect over the y-axis, you get back the same blue original graph. That's what that means. But in the second case, if you want to make it a odd function, so how do I change it? Is let's take one point right here, which is 3, and maybe this is like 3 and 25, so I have to go other side as minus 3, minus 3. So if this is from the origin, then I can reflect on the other side, which will be negative 3 and negative 25. So your new graph will be this one, but you'll have to extend on the other side and goes like this again. So this will be a odd function. So if you want to have a h function, this h graph is minus of f of minus x. So make sure you understand this part. The new graph, this pink color is basically you do the reflection over the, it's like you reflect this way, see this part? So it reflects over the y-axis, and then it reflects over the x-axis. So this thing to this point, it's not good. Like something like this, right? So this point reflects like this. So first this point goes this side and then reflects this side. So hope that helps. The main thing is to know that this one is, if you have, when you graph like this, that's even, but if you graph this way, that's odd. Okay, this question is a linear function f given, this is given to you. So the question is, what should be m and b so that f is even function? Now remember, even function means if you have anything like say this part is even, because if you reflect this over the y-axis, f of minus x is f of x. That's what should happen. Now what does this mean? Mx, if I write y equals 3x minus 5, basically your graph is start 1, 2, 3, 4, 5, and there's the rise over run, which is 3 over 1. And if you go 3 up, 1 right, 3 up, 1 right kind of thing. So you kind of get a line like this. But I want a line that, through the origin, you want to have it like an even function. And for this to be true, if this is the line, you want to have f of minus x equals f of x, right? So that means if you reflect, now if you reflect this line over the y-axis, it will go this way, so it will never coincide. So what is the only option here will be is you'll have to take slope equals 0. So here this m will have to be made, m has to be 0, and b could be anything. Let's see why. I'll take it like this. So your equation becomes y equals 3. So no slope. That means any line 1, 2, and 3, I can draw a line. You see like this. And this line, if I take this, if you reflect this over the y, you get back the same line. Why only that? It could be this line, it could be this line, it could be any line y equals b. So this b could be anything, m should be 0. So the answer for this is y equals m should be, so the answer is m has to be 0. B could take any value. Now in this example, what if they had to ask us about what should be b and a, so that it is a odd function? Then you'll have to do, they give it even. What if this was odd? Okay, this is so the line that we have to do will be this one. For this part, it will be like y equals x. It means y equals minus x plus 0. Because if you have a line this one, and if you try to reflect twice, you don't get back the same thing. So this does not reflect over the origins. This is the only one through the origin. If you reflect twice, it means you first reflect on the y-axis, goes this way, and then again reflect over the x-axis, you get back the same thing. So that's how this is. So let's go to the next question. So if you see in this case, there is two graphs. One is the green color and one is the blue color. So now which one is blue and which one is green? So that's the question here. See, now when you look at it, this is like the main graph, so f of x. And if you see the second one, in place of x, it is the input is x minus 1. Now what that means is this basically means, so we know that when x, if you have x is replaced by x minus 1, that means the graph shifts 1 unit to the right, because of this minus. So you just make it like a opposite. If there's a minus 1, means it shifts to the right. That means your f of x is this one. The green color is the f of x, and the blue color is the f of x minus 1. So if I try to draw a horizontal line, so here at 50, what basically that means is, and I don't know where exact, this will be at the location of minus 4, and this is at the location of minus 3. So this is minus 4 and this is minus 3. See this point? So the output for this function, this let's call this as gx function, this output, whatever the output here is, which is 50, this is 50, this output is already being done here. This is this 50, the f does it 1, so the this gx is, so I'm gonna, let's call this as gx. So the gx, okay, now in this case you're given a blue color graph. So this is important. This is the main graph. Let me make it a red color. And this is the fx graph. Okay, now you are supposed to write expression for the other graph. So starting with a, look at a. So the a is this one. Let me use a blue color for that. So how should we write the equation? And if you see, the graph has shifted to the left. So the original function, this one, let's put this point. So if this point is 2 and 4, now it moved 1, 2, 3, 4, 5 and 6. So it moved 6 places to the left. So we can write, okay, if this is a function, the new function a, this part I can write ax. We can call it ax. So ax is f of x. Because it's shifted to the left, you can write f of x. But 1, 2, 3, 4, how much? 1, 2, 3, 4, 5, 6. Yeah. So you'll have to put plus 6, and that's it. So shifting the graph to the left is to the plus 6. Now what about b? And you can see the graph of b is shifted up. So this graph is shifted up. This part. So by how much? If this is a point, it goes 1 and 2. That means your new graph b of x will be the original function this, and it goes up plus 2. Then at the same time, let's do also the d graph. This is moved down. So how many places did it go? This was the original, so you go 1, 2, 3, 4, 5. So this d graph will be the original function f of x and minus 5, and you're done. But the last one, which is red color, was this one. Look at this graph. So this graph is, the dot is right here. So you see there are two transformation happening. One is one. So that's the blue color graph which you see there. So this point which is right, it moves 1, 2, 3, and 4. So because it moves right, the new one, Cx, because there's a C, I put Cx is the original function moves to the right. So you have to put x minus 4, and then it goes 1, 2, and 3 up. So you put plus 3, and that's all you do, see. So this is how you create function or write equation for the new graph. All this basically means you shift 4 units to the right. The number by itself means it goes up or down depending on positive, negative, and that's the opposite one. So this problem is almost similar to the one that we did earlier. So I want you to do it on your own. As one problem I want you to try. So it says reflect over the x-axis, and use the color pencils to do that, and then over the y-axis, and what do you get? So is it going to be even, odd, or neither? So that's all. Now I'm going to do the next video will be on practice problem number 7. This is practice. The one that we did right now is practice problem 6. So hope you're getting the idea of conceptual understanding of how to write even and odd function.